In today's presentation, we're going to be talking about the Zebraborns team, what we've done this year, and also a little bit about each of the sub-teams, and also about some of the business and outreach we can involved. So first of all, what is FIRST? And so FIRST is a robotic competition that stands for Inspiration and Recognition of Science and Technology. And it's broken up into 4 different categories, each targeted for a different age group and skill level, including LEGO League Junior, LEGO League, Tech Challenge, and FIRST Robotics Challenge, which is the one that the Zebraborns competed. And we currently share a lab with 4 FLL teams and 2 FTC teams.
So I'm Donald. I'm a junior, and this is my first year on the team. The FIRST robotics competition is a competition between high school students where you work to build a 100-pound robot in just a period of about 2 months. You have to go from just parts around the lab to a fully designed robot through different methods. The robots are traditionally designed to do 3 game challenges, all of which require students to think innovatively and understand what they're doing. This year's game was Destination Deep Space, and we have a video to describe the game.
Welcome to the 2019 FIRST Robotics Competition and this year's game, Destination Deep Space, presented by the Boeing Company. 2 alliances of deep space travelers race to place hatch panels on their rockets and cargo ship, load valuable cargo for transport off the planet, and return to the safety of their habitat, all before the next sandstorm sweeps through. Each alliance has 2 rockets, 1 cargo ship, and a habitat. Hatch panels and cargo are available through the human player stations, and cargo is also available in the depots adjacent to the habitats. Robots start in their habitat and may be preloaded with 1 game piece. Alliances may also choose to preload some bays of their cargo ship with either hatch panels or cargo. During the first 15 seconds of each match, driver vision of the field will be blocked by a waning sandstorm. So robots must be controlled using either autonomous code or manually with a vision system on the robot. Alliances earn points for exiting the habitat, securing hatch panels, and any cargo that's properly stored. Cargo not secured spills from the cargo ship. As the sandstorm ends, driver vision returns, and alliances continue to earn points by loading their spacecraft. Alliances earn a rank point during qualifying matches for completing 1 rocket with hatch panels and cargo. Near the end of the match, robots return to the safety of their habitat for the upcoming launch and to earn more points. The alliance that earns the most points wins the match.
So as you can see, the game requires students to think innovative ways to solve different problems.
Who are the Zebraborns? I'm Edward. This is my first year on the team. I'm a freshman. The team was founded in 2002, and we're based out of Durham, North Carolina. Originally, the name of the team was Team Infinity, but we later on changed that to what you see now, which is the Zebraborns. The majority of our students are students at NCSSM, but we're also open to anyone who wants to join from other schools all around the state. We have 38 students on our team, and this year during the build season, all of our students accumulated over 5,000 hours in the lab. And NCSSM takes students from all over the state from different socioeconomic and cultural backgrounds, and this transfers a lot into our FRC. This year, over the course of the competition season, we won 3 different awards. Well, 2. The first award, which we won at the Wake County District event, was the Innovation and Control Award. We won this award for our accomplishments with autonomous alignment and our intuitive control systems. The second award we won, which was at the UMC Asheville event, was the Team Spirit Award. We won this for our efforts to improve the community and through our extraordinary Tiger program. And then lastly, at the North Carolina State Championship, we won the Innovation and Control Award for a second time.
Hi, my name is Yashis. I'm a sophomore at Van Creek High School, and this is my second year on the team. So Team Hunter, we have 4 sub-teams. We have programming, mechanical, strategy, and partner relations. In order to streamline the communication between our sub-teams, we use a powerful task manager called Zenmo. This task manager is also used by industry professionals. So our season is broken up into 2 parts. We have preseason and build season. Preseason lasts from August to December, and during this time, we train new and incoming members, and we also work on experimental projects. We'll share some of our projects throughout the presentation. Second, we have build season. This lasts from January 5th to February 19th. During this time, students work to set deadlines for our individual sub-teams, and also work to progressively and iteratively design, build, and program our competition robot. So the first sub-team I'm going to talk about is our strategy sub-team. Strategy deals with making competitive decisions for our team throughout the season. During build season, strategy deals in something we call initial analysis. This happens during kickoff when the game rules are just released. We have a small team break off and do an in-depth analysis of the rulebook. And we use this analysis in order to formulate design requirements and our priorities during build season. In addition, during competition season, strategy works to collect and analyze scouting data. So scouting data is collected by using an app in which students can enter team ability data, which is then used to populate a custom database and is visualized using Tableau. Tableau is also an industry standard visualization software. The strategy team also uses this data to do statistical analysis and mathematical modeling in order to do a sort of predictive analysis, which helps us make strategic decisions throughout competitions.
I'm Clara. I'm a junior at North Carolina School of Science and Math, and this is my first year on the team. And I'm going to talk about the programming. And so, our programming team uses ROS, which stands for Robot Operating System. We were the first team to run full stack ROS. And with ROS, it's not exactly an operating system, and more of a user-contributed library of software, and it comes with simulation, visualization, and all kinds of libraries that we can use, as well as packages with sensors. And it's also really modular. And so with this, we can expand our programming team by breaking up tasks and having different groups work on different parts of the code. And we can also, because of its simulation libraries, we can test our code without having to use a physical robot. And another interesting thing about ROS is that it's used in industry and academia with warehouse robot companies and NASA robotics research. And it's really cool that we get to use it. And one of the programming projects that we worked on this year was AutoAlign. And so with AutoAlign, we have distance sensors that can sense how far away the robot is from the size of the rocket. And then also we have a stereoscopic camera that can sense the reflective tape above the target. And then this and our swerve drive, which allows our robot to go in different angles. The robot is able to align itself directly in front of targets and the right distance away.
One of the long-term goals of our programming team is to develop a fully autonomous robot. And this year we worked towards that by implementing a lot of automated timed actions. One of the greatest examples of this was our elevator, where we used a variety of sensors to determine what type of game piece we had. And then based off of that, we would automatically bring the elevator up to a certain height to place the game piece.
My name is Aditya, and I'm a sophomore at Greenhope High School, and this is my second year on the team. So on the mechanical team, one of the first things we do when the game challenge comes out is we take the strategy that the team voted on, and we create a list of design requirements. This details what we want the robot to be able to accomplish, and we don't think about mechanisms at that point. We're just thinking about specific tasks that need to be accomplished. And then we go into the mechanism stage where we start brainstorming different mechanisms with research of what's used in industry as well. and then we prototype those things. We iterate on our prototype many, many times. We never have a final version, and it's always keep improving. And once we have our prototypes, before we begin the final assembly, and throughout the whole process, we're using CAD, which stands for Computer Aided Design. Specifically, we use SolidWorks, and what CAD allows us to do is visualize the exact robot and how the things fit together, and troubleshoot possible problem spots before they actually come. And we can also send off parts to sponsors via machine. We can get parts built in our fabrication lab here on campus, and we can develop parts to be 3D printed, which was a huge part of our design this year. And so for the past 2 years on the mechanical team, we've been running a custom sloped drivetrain. So in this drivetrain, we have 2 motors on each module, one of which powers the drive and one of which powers the rotation. So this allows for multi-directional control, which gives us a huge advantage in many, many games. And this past off-season, we designed our slope modules to be approximately 3 pounds lighter for each module, and this gave us a significant help in weight this year. And when we were redesigning our modules, one of the main design challenges we came up against was where to position our motor controllers. We ended up deciding to stack them one on top of another and have them inside a custom 3D printed gearbox through which they would detect a coaxial shaft to determine the position of the wheel.
So one of the biggest accomplishments we made this year was to complete the climbing game challenge. It was a very difficult challenge because you had to free climb up against a wall onto a platform. And we achieved this by having a collapsing foot method where we would push a pair of stilts under the robot to raise our robot to about 2 feet into the air. And then we would have a foot collapse up inside of that, have the robot fall forward onto the platform, and the stilts will be pulled back up into the robot. And it rests on these little stilts that pop out from the underneath of the carriage to support the robot so that the back wheels can actually rest off of the platform. This, we were able to do this by use of pneumatics, which allows us to put such complex mechanisms in a small space, and by using custom machine parts, so that way we can make it small, light, and to the exact specifications we needed.
Sorry about we got a little too excited there. Hello, my name is Mahesh Badi. I'm a junior at the North Carolina School of Science and Math, and this is my first year on the team. As a team, we do a lot more than just interesting mechanical and programming projects. We also want to reach out to a diverse group of people and spread our love of robotics and nurture that love of robotics. One of the ways we do this is through our team. As you can see, our team is from all over North Carolina. And each one of these team members, we're able to nurture their love for robotics. And by nurturing their love for robotics, we're able to spread the love for robotics every single place they're at. Because when we spread it to one person, they want to spread it to everyone. Robotics is cool. Other than just that, some of the things that we do is that we coordinate outreach events. In order to help spread the love for robotics, we want to go talk to people and help spark their interest, and maybe even get them involved in first, and maybe even get them to join our team. Some other things, well, one of the other big things that we do is presentations to industry professionals. We really like to give presentations because we're able to share what we're doing and show that what we're doing in FIRST and what we're doing in terms of robotics is some pretty cool things, it's some pretty serious business. And one of our biggest presentations that we did is at ROSCON in Madrid.
So as Mahesh said, this past September, we had the honor of giving a talk at the International ROS Conference in Madrid, Spain. And at this talk, we were able to talk about how it was for us using ROS on FRC-specific hardware and software, and also some of the challenges we face, including trying to automate certain actions like robot motions and motion planning. And we also got to speak to industry professionals about their use of ROS in their everyday lives and like struggles they face, and really connected with them in that way. And they also gave us some recommendations for programs and algorithms intended to reach out future region how we did. And throughout this experience and preparing for ROSCON, we were able to learn how to talk to academia and also how to network with industry professionals. And it was a really valuable experience for us.
Other than the presentations and outreach, we did quite a few other things. One of the things that we did this year is that we hosted an FLL scrimmage. FLL is First Lego League, and by holding the scrimmage, we were able to help teams prepare for their upcoming tournaments. Another thing that we have is our TIGER program, as we talked about before. TIGER stands for Teaching Innovation, Graciousness, and Engineering Through Robotics. And through this program, we're able to help rookie teams get on their feet. We teach them basic mechanical and programming aspects of robotics, and teach them about sustainability to help sustain their team over the years. We also continue to talk to them through student TAs and mentors to make sure that they're doing well, and so that we can continue to help them. And through this program, we've assisted 64 other FRC teams, some even being international, from Turkey, New Zealand, and Israel. And one of the biggest things that we've done this year is that we took our whole team to volunteer in Houston at the first championship. By doing this, we were able to give back to our community, and we were able to give a presentation in Houston about ROS, which we found to be really nice. And none of this would have been possible without you guys, our sponsors. And so thank you so much for all the support you give us and for all the things that you do. And thank you for taking your time to come over here and listen to us. Please feel free to stay and talk to us about anything that you want on this presentation or more. And thank you.